So hello friends, today we will be solving this new question. In this question we will be covering an important concept of rolling over an inclined plane, and we will be discussing what are the key points that are necessary to solve these types of question and what should be the process that needs to be followed while solving these questions, right? So without any wasting time, let's begin. So what is the question? A spool with a thread wound on it is placed on an inclined smooth plane at an angle alpha equal to 30 to horizontal. The free end of the thread is attached to the wall as shown. The mass of the spool is m. Its moment of inertia relative to its own axis I is I. Radius of the wound thread layer is r equal to 3 centimeter. Find the acceleration of the spool axis, right? So we have to find the acceleration, right? So first of all, what is a spool? A spool is a object something like this. It is cylindrical in between and on its two ends with the radius greater radius in between and lesser on the sides. So when we see it from its cross sectional, then we will see something like this. This radius would be r, capital R, and this would be small r, right? And we are given that r small r equal to 3 centimeter. And we are also given that the moment of inertia of this spool about its axis. So what would be the axis of the spool? So the axis of the spool would be this, right? So we are given the moment of inertia about this axis, that is I. Okay, so I will be solving this question in the form of variables. You can put the values in the result that we will obtain, right? So and also I will be using here theta instead of alpha to maintain clarity in my variable declaration, and I will be using angular acceleration alpha as angular acceleration as alpha and linear acceleration as a, right? So so what would be our first step while solving the question? So first step would be analyzing what type of motion is our system is performing. So as you can see, we are given that the inclined plane is smooth, which means the friction is absent. Thus, it would be performing some type of motion, but it would not be pure rolling as the friction is absent, and thus the spool would be sliding on the inclined plane, right? So as you can see, the the forces that are being acting on the spool are first of all the gravitational force, that is mg sin theta in this direction parallel to the inclined plane, and mg cos theta perpendicular to the inclined plane, and another force would be tension, right? Which would be at distance r, and any all other forces, there is no other force, right? And there would be a normal force in this direction which would be balancing the cos theta component of mg. So we have to just analyze in the plane that is parallel to the inclined plane, right? So these are the forces that are acting on the spool. So as you can see, there is a torque about the center of this spool, center of the axis of the spool, right? There's a torque that is being acted by the tension force or the string. So this spool would be having an angular acceleration in this direction, right? Let's say it is alpha, and it would be having an a linear acceleration in the direction downwards, the inclined plane, right? Let's say it is a. So what we can infer is that this spool is performing a rolling type of motion, but that rolling motion is not pure rolling, right? So the next step would be to find the relation between alpha and A. So how can you find the relation between alpha and A? So if you observe the inner radius of the spool, that is this part, and the string that is wound around this radius, and it is unwinding itself while the spool is moving downwards the incline, down the incline, right? So this is a string that is attached to the inner radius, and let's analyze this point and this point of the uh, string and the inner radius, right? Let's name it as A and B. So as you can see, as the string unwinds itself, the velocity of A and B would be same, as these points are in touch with each other, so their velocity would be same, right? So what we can say from this is, let's say if at that instant when these two points were in contact, its angular velocity was omega and its linear velocity was v. So what we can say, the uh, the velocity of point A and point B would be same, right? So what from as you can see that point A would be on the string, and string is not moving. So this means that the velocity of point A is equal to 0 as string is not moving. Thus the velocity of point B would be equal to 0, right? So what would be the velocity of point B? Velocity of point B can be written from this diagram. As we can see, its velocity would be v minus omega into small r, right? It would be equal to 0. So omega equal to v by r, and by differentiating this equation, what we can say, d omega by dt equal to dv by dt upon r. D omega by dt is equal to alpha, right? So alpha equal to a by r. A was linear acceleration, dv by dt equal to a. So we have found the relation between alpha and a. This is the first equation. Now the next step is to write the force equation parallel to the inclined plane, right? What are the forces acting parallel to the inclined plane are mg sine theta minus t is equal to m into a, right? Right? Yeah, right. So this is the second equation, and the third equation would be writing the torque equation about the axis of this uh, of this spool, right? As we are given moment of inertia also, so we will be writing about the axis of this spool, and as this spool is accelerating, so we will be applying a pseudo force on this spool, but that pseudo force would be passing through the center of mass of this spool itself. It would be passing from this point only, so it won't be having any effect on a torque equation, as its torque would be 0 about this axis that is passing through the center of this spool. So its moment of inertia would be 0 at that. The only force that is causing or making this spool to rotate or giving a angular acceleration to this spool is the tension force, right? So we can write T into R is equal to I into alpha. This is the torque equation. From this equation we can say that T equal to I alpha by R, and we can substitute alpha from this equation to here, and I a by r square, T equal to I a by r square, right? This, and we can substitute this result in second equation, mg sin theta minus Ia by r square is equal to mm, right? So calculating from this equation, what we get is A is equal to mg over m plus I by r square This is the final answer, right? So this was a required answer, and we have found that. Yeah. Okay. Yeah, it is done, and you can substitute the values of the variables in this answer, and you will get the final answer. So if you are having any doubt, then you can post your doubt in the comment section, or you can also join the Telegram group. I have given the link of that in the description, so you can check that. So yeah, that's all for today, and let's meet in some other video.